Okay, so now that it is recording, let me share my screen. I'm just thinking. Okay, so the lesson is on Compass. There's a few things that we'll go through, and let me update the role as Keith is here. Is that what I want? No, not this. Not that yet. Where's my PowerPoint? Right here. No. Okay, so this one. Let me open the chat just in case you want to say something. All right. So we look at the Cartesian plane, the coordinates, and the linear graphs using a table of values or having two points with their coordinates. Hi Gaith, I updated the role already. So very important concept is later on when you see we looked already at linear equations, and when we look at a specific one which is the linear graphs, in the rule is in the form y equals mx plus c. M is defined as the gradient, which is part of your vocabulary, one of the key terms. It is defined as the ratio or a fraction or a division of what we call the rise over the run. Um, I will put this PowerPoint on the lesson so you can have that for your reference. Um, the rise is annotated going upwards when it's positive, so it's the vertical measurement or difference that you annotate, and the run it's from the left to the right, so it's across. Okay, so the run is in the same direction as the x-axis, and the rise is the same as the vertical y-axis. If you go in the opposite direction, either for the rise or the run, that's when you use the negative values, and that's what you know about integers. When you have a negative amount, it's in the opposite. It's a change in the opposite direction. Okay. So let me go through a few examples. So let's say you have a straight line given to you. You get 2 points here. What you would do is it's annotated here. You will create a right angle triangle. And what you do is you will annotate across, you pick one point. It doesn't matter which one. You pick a starting point. And what is the path that you would choose to go from this point to that point using the rise and run. So the rise will be to the right and upwards, and depending on the scale of your Cartesian plane, here a large square represent a unit vertical and a unit across. We get a +1 here and a +2. Then you can write your gradient as the rise is +2 and the run is +1. And 2/1, it's a positive divided by a positive is still a positive, so you don't need to write the sign. And 2/1 can be simplified as just a value of 2. So the gradient is 2. Okay. Um, any question for this example? Okay. Next one, another line. You have the coordinates of 2 points. The crosses indicate the 2 points that are chosen. You annotate your rise vertically and your run. So we start from this point to go to that point. From the first point, you go +2 to the right, +3 because it's upwards, and you write your expression for your gradient, +3/2, which is 3/2. Any of you know what it is equal as a decimal? I think you do that backwards. Yeah, okay, so it's going to be 3 divided by 2, and 3 divided by 2 is 1.5. Okay, so that's another, it's equivalent. As a fraction is 3 over 2. Can you give me another equivalent fraction as an example? There's an infinity of equivalent fraction. They don't need to be the simplest form. Anybody can come up with a different one? If you don't remember how to get an equivalent fraction for 3 over 2, when you have an equivalent, you will multiply or divide by the same amount. So if I wanted to find an equivalent and multiply by the same value, and you pick a number easy enough that is on your times table. So let's say I multiply by 5, I will get 15 over 10, and that will be an equivalent fraction, and it will be still the same gradient. So yeah, what you did is you multiply by 4, 3 times 4 is 12, 2 times 4 is 8, 12 over 8 is equivalent. So what you could do, instead of going 2 units to the right and 3 units upwards, you could go 8 units across and 12 units upwards, and you will still be on a different point, but on the same straight line. Okay? All right, a couple more examples. Okay. The 3 is the rise. So I have 2 points, A and B. First step is to choose which one is your starting point. We start from A. It doesn't really matter, you can start from B, but usually we go from the left to the right. So if we start from A, what is the path that you need to do using the rise and run to go from A to B? So you go 2 units to the right and 3 units up. Because it's 3 units up, it's positive 3. And because it's to the right, in the same direction as your x positive axis, it's going to be a positive 2. Okay? All right, 2 points. So you have your Cartesian planes. It's annotated here. You have your squares that describe a unit. You have your straight line. And you have your slightly in darker red. You have 2 points. Here is -1 and 2, -3. You don't really need to pay attention to the coordinates. Later on with the coordinates, you can use a formula. But here what we're going to do is the visualization on this Cartesian plane. So I'm going to overlap the arrows. In blue, it's the run to the right, and vertically, it's the rise. So can you tell me the value of the run? And you have to make sure it's the correct sign, positive or negative. So looking at this, I think you can see, right? So in blue, what would be the run? Yep, so it's 3 squares and it's to the right, so it's positive 3. And vertically, it will be the run, positive or negative, and the amount. Yep, so what would be the gradient value then? Don't need to simplify, just use the formula rise over run. Yep, 4 over 3. So before, we know it's 4 over 3 is the answer that you simplified already. But let's say we keep the positive 3 and a positive 4. Positive 3 divided by positive 3. You can simplify the positive divided by a positive. That gives you a regular positive value. So we can remove the positive sign, and that is a 4 over 3. Okay, and this is the simplest form. You could always also do that as a decimal. So if you do that on your calculator, you do 4 divided by 3. That will give you an approximation of 1.33. That is continuing. It's also equivalent. Okay, in general, try to write your gradient as a fractional form, but sometimes the decimal form could be a nice um, um, definite fraction. So for example, 1 over 2 is 0.5. 0.5 is fine to write. It's it's fine. 1/3 is a little bit different because it will be 0.33 to it will keep recurring, so that's not a good notation. But most of the time you can write either in fraction or decimal form. All right, another situation like you have a line, you have two points. I will overlap the arrows. Can you tell me first in blue is the run? What's the value of the run? Yep. And what's the value of the rise in orange? Okay, so you'll agree because it's going downwards. Don't forget when you go in the opposite direction to change the sign. So then your gradient is -1 divided by +5. If you remember, when you have a negative divided by a positive, it's simplified to a negative. So the convention, oh wait, ooh, I didn't do that. The convention for this is to write it as there's two ways you can do that. You can put the negative in front of the fraction, like that. So you can write -1/5, or the negative coefficient will be with the numerator. So it will be -1/5. Okay. As a convention, you don't put the negative on the 5 instead of the 1. It's not incorrect, it's just harder to read because the convention is to put the negative on the numerator of the fraction, which is easier to notice when you look at a fraction to see if it's negative or not. Okay, so keep the negative either in front or on the numerator when your fraction has a final sign that is negative. Okay. All right. I'm moving on to a work example from JAC Plus, which is work example 5 from 7.3. It's on the lesson plan. So it has 4 different parts. What you need to do is find out the gradient of those straight lines. Okay. And what I'm going to do is I'm going to stop my PowerPoint and I'm going to use my paint to show you how I'm annotating the arrows for the run and rise. So for example, A here, you have your straight line here. It gives you the coordinates. Can you all see the scale a bit, or do you need me to zoom in? Actually, I can zoom in a bit. I just need... Okay, so that's example A. It placing the dots, so it gives you 2 points on the straight line. If the straight line doesn't give you any point, you can choose any point on the straight line. Just choose them so you get whole number values if possible. Sometimes you won't be able to, so you will have to approximate. So here you have it's 2 squares, it's a -2, and it's also, you can read the coordinates here. So by doing the rise and run, what I do is I have 2 points here. I'm gonna start with from the left to the right, and later on I'll do another example when I will start from the right and go to the left, and you will still get the same gradient. Okay, so here I start from this point to that one, so you have to use the grid to visualize that. So I'm going to change to my arrow. I'm going to pick blue for here. I'm going to start from here, and what I'm doing, I'm going to go for my run and line it up with approximately, it's actually to 10. Okay, because that lines up with the x coordinate of that point. Okay, so I have my run across. Orange was the color for the rise, so I'm gonna go, I need to deselect this. I'm going to do this. Yeah. So I'm going to go from here. I forgot. I thought I changed the color. So let me change color. So I go from here upwards. Okay. That is my run. So what's the value of the run? Sorry, that was the rise. What is in blue? What's the value of the run? And make sure you specify the sign in front of it. So positive or negative. Okay, as I was mentioning, the run is across. Is it going, it's going to the right? Because I'm starting from this point and I'm going towards the right, so it's going to be positive. Correct, it's 10. Okay, and vertically is the rise is going to go from, just have a guess at the value for the rise. So I'm going to go from here all the way up to that point. Okay. To get 15 is we start at -2, so you can use that coordinate that's -2 to clarify, and you go all the way up to a 13, which is given over here, or you can read across as you project across to your y-axis. That is your 13 value. So it's positive 13 over 10. So 15 over 10 is our gradient. Okay, it's positive. It's not a simplest fraction, so it's still correct, but we always like to simplify. What is the common factor between 15 and 10? And we can simplify for that amount. So what's the common factor between 15 and 10? 5, correct. So you divide both numbers by 5. You don't multiply because you want to simplify them, you want to make them smaller. And you all agree that will be 3 over 2. Okay, so 15 over 10, when you divide by 5, both numbers, that gives you 3 over 2. Okay, yeah, it's the same answer, but it's a different example. Okay, all right, that one, just need to move a bit. I'm gonna move that. Okay, so I have 2 points here. Again, I have orange, so I'm gonna do, I have a point on the left and a point on the right. Okay, so now I'm going to do, just to change it around, I'm going to pick the first point to be on the right, and I'm going to find the run and rise to get to that second point, which is on the left. Okay, so I'm in orange, so I'm going to do the rise. So I'm going to go up or down because that point is lower. I'm going to go up to here, roughly. Okay, and then I'm going to change it to blue. No. And from that, I need to go and connect to that point. Okay, so the rise is in orange, it's going upwards, so the rise is going to be positive, and the amount is going to be, it's a little bit hard to read the scale because you can see that it's increasing in, I'm not sure, it's 5 squares between -20 and -40, but what you do is use the coordinates here. Okay, so the coordinates, you're going from -24 all the way to 6. So how much is that? What would be the increase to go from -24 to +6? Yep, so the rise is +30. What about the run? Can you tell me if it's positive or negative? Yes, correct. So it's going to be negative, and we go from the coordinate is 10, and we go all the way to 0. So it's going to be negative 10. Okay? So the gradient is going to be 30 divided by negative 10. Do you remember the convention for the negative? When you have a positive divided by a negative, if the final answer is negative, the negative will go in front of the fraction. What if we did it on the bottom side? What do you mean good question. Now, the spoiler answer is you should get the same answer, and I will do it. I'll demonstrate in a second to use a different triangle and show you that you will get the same answer. So let me finish this one. So the gradient is 30 over negative 10, and that simplifies to a negative. And 30 divided by 10 is just 3, or 3 over 1. So the gradient is negative 3. Okay, so Kiara is asking, I hope what you mean by the bottom side is we start with this point and we still end up with that point, but instead of going up and then left, you want to go across here and then up. Is that what you mean, Kiara? Okay, so let me use, I want to delete those. So I'll put in the chat, the gradient is negative 3. So we have that already. Okay, so I have the arrow, I have blue. Yeah, so blue, I'm going to go from here to back to here, like that. Okay, vertically from this point, and I go up here. Okay, and what you can see is in orange, that's your rise, that's positive. It goes from negative 24 to 6. It's still going to be positive 30. Your run is from 10 back to 0, so it's going to be negative 10 because you're going to the left. So again, the gradient, which is your rise over run, which is positive 30 divided by negative 10. It's still the same. Okay, so I hope that clarifies. It doesn't matter when you have 2 points. It doesn't matter which point you start with. You can start with this one, or you can start with that one. And you have 2 ways you can go. From this point, I can go under, to the left, and up, or you can go up and to the left. When you do the rise over run, you still should end up with the same answer. Okay? All right, let's move on. I want to do... So if we do right and down, it means I will start from this point. You will go to the right and down. What you end up is having your run to be positive 10. But now your rise is going to be negative 30. And negative 30 over positive 10, it's still going to be negative 3, if that makes sense. I'm going a little bit fast, but it's the same answer. I'll do a couple more examples, and I will change the points, the starting points, and the direction, or how I make my triangles to show you that it doesn't matter which way you pick. Okay? All right, so with work example 5, there's 2 more. There's C and D. With this one. So this one I want to move. That over here because I need the colors. All right. So here you have a straight line. You need to pick 2 points on a straight line. Okay. What was the notation they used before? I think they did little crosses. So in green. So if I do something like that. So and I pick anything. Probably I pick one on the y-axis. So this one. Okay, and I'm going to pick one that is lining up with 5. just to make it easier. Okay, I'm going to go from the left to the right. So again, I need my arrow. I need to be in blue because I chose blue for the run. Okay, so what's the value of the run? It's in blue. I hope you can see. I didn't pick the right color, but is it positive or negative? Positive. And how much? What's the amount? Correct, 5. I picked that point on purpose, so it's easy to label it down. I could have gone further. I could have picked this point and lined it up with 10. I would have ended up with 10. Okay, so the run is positive 5. And notice I didn't mention the rise. Okay, so let's go now with the rise. I'm going to change color. But I've got a problem now. So what's the rise? I can't. Those points are horizontal. Correct. So I can't do a rise like that because it's actually, there's no vertical increase. Does it make sense? So I can't put a vertical arrow. So I need to remove that. So I'll write the rise is 0. Okay. Now we know the rise is 0 and the run is 5. Write that as a fraction for the gradient. What's the formula? What do I write for the gradient? Remember, it's the rise over run. I'm going to put that in the chat as well. Correct. It's 0 over 5. Now, what's 0 divided by 5? Tyler, if you have $0 and you share it among 5 people, how much do you have left? How much each person have? Still 0. You can split 0 in any number of shares, it's still going to be 0. So it's 0. The gradient is 0. So for this situation, you see the line is horizontal. The gradient is 0. Okay. All right. Last one I want to go. The line is this time vertical. I'm going to pick 2 points here. So I'm going to pick one at -10 and one at 0 here. Okay. So what's the run? Correct. See, those 2 points are lined up. I can't have an arrow going across. Oops, that's not the arrow, is it? That's the arrow. So I can't have an arrow going like that because they have the same x coordinates. They all lined up. So the run is 0. What about the rise? The rise is in orange. It goes from this point to that point. And I pick from -10 back to 0. So the rise is +10. Correct. All right. Write the gradient as a fraction and tell me the fraction for this example. Yep, that's good. Okay, so yes, the gradient is +10 divided by 0. Do you remember anything about what's happening when you divide by 0? Try to do it on the calculator and see what happens. Now, do you remember when the gradient is equal 0? It's what we did before. It's when the line is horizontal. When it's vertical, you can see those two lines are very different. They can't have the same gradient. Here the gradient was 0, and here it is actually not 0 because it's a different situation. Now, Chiara's, when you said it says not a number, what it means it's undefined. And what you need to know is every time you do a division by 0, it's what we call, it will create an error. It's what we call, there's different ways we can call it. It's undefined. But in this situation, because the line is vertical, it's when we say that the gradient is infinite. Okay, so the gradient is undefined or infinite. Okay, and this is kind of the definition of a infinite gradient. So I can go across a certain amount, but you see it's fully vertical. Okay, so to summarize, when a line is horizontal, let me write in black. So the line is horizontal, it's parallel to the x-axis. So the gradient is, pardon my writing, I'm using a mouse. So that's 0. Okay, and when the line is vertical, the gradient is undefined, or the infinite symbol is this one. Okay, the gradient is defined, Kara, as the ratio of the rise of a run, and the convention letter is m. It's just a choice of a letter to describe the gradient. Okay. All right. Now the last thing I want to mention is, so hopefully it gives you a better idea how to calculate the gradient. The last thing I want to mention is this one. So have a look at this question. I'll put it on the so you have a graph here, 3 different straight lines, different colors that represents different meat. Vertically you have the cost in dollars, and across it's the weight in kilograms, and calculate the gradient for each graph. What I would do here is, when you see it's 1 here, I would have a vertical line. If you have your book, do that, or you can do that on the screen, you do that. So you see that beef is the blue line. It crosses at about between 5 and 10. So what's in the middle of 5 and 10? You can't be wrong, really. Okay, let me round this up a bit. It's 7.5. Remember, when you have a cost in dollars, you can go to cents. Okay, so I know you think about mathematics, so you round it up to a whole number, but you can always think as a decimal. So it's for beef, it will be 7.5 for 1 kilo, which is your gradient basically, because it's 7.5 divided by 1. Okay. For chicken, it's in green. What would that be for chicken? It's actually quite of expensive, but yeah. Yeah. So chicken is 10 for 1 kilo, and 10 over 1 is 10, so it's also the gradient. And for the lamb, it's 15. In brackets, I'm going to put the units. It's actually dollars for 1 kilo or per kilo. Okay, so the application of linear graphs is anything that related to prices per weight. So anything that when you go to the supermarket, things like meat, fish, fruits and vegetables that are sold not per unit but for them based on their weight. And then from that, let's look at the extension question, which is this one. So by choosing the gradient, I'll actually answer question B. What is the cost of 1 kilogram for each type of meat? But now, what is the cost of purchasing 1 kilogram of lamb? I think that's the easiest question, because I think it's straight away 15. What about 0.5 kilogram of chicken? It was 10 kilogram, $10 for 1 kilo, so it's going to be $5 for half a kilo. And what about 2 kilograms of beef? If we were 7 for a kilo, that would be 14. Let me check what it goes here. Is use the graph to your advantage. When you have 2 kilos here, you can see that beef is crossing at 15. So you write 15. Okay. All right. So I think that's all I have on my end. So let me stop that. It's gone. I can stop the recording. I think that's it. Stop sharing.